today I want to talk a little bit about welding, particularly stick welding. It's a process in which you take an electrode and put it in an electrode holder and actually start welding. This type of welding requires a good deal of practice, to acquire the skills that you need to melt that rod in to make a filler metal, put a filler metal in to make the weld. Starting out with what it takes to do it with, well, you got your electrode right here. Now this is your typical everyday 70-18 electrode. My personal opinion, the best electrode that there is out there for everyday common welding. They do require quite a bit of skill, but once you learn to run a 70-18 on mild steel, you put a good weld in there, and in my opinion, you can't break it. If you put enough weld on there, it'll just stay forever. They're easy once you learn them. The hardest thing about a 70-18 and working with students is I usually start them out on another type rod, like a 60-11, possibly 60-10. They strike easier, and then once they learn to strike that arc and go with it, then I graduate them on up into a 70-18, because when you get out into the workplace, this is the rod you're going to be using the most. And it's the one I have used the most in my years in the business. Now, if you can see, here's where your rod would go into your electrode holder. Or, out in the field, that's known as a stinger. I really don't know why. If you get stung with it, I guess you took a little bit of electricity. But anyway, it's known as a stinger, but it is actually the electrode holder. It goes right in there. That electrifies this when you strike an arc. I'll talk about that here in a little bit. But the electrode itself, you got your core, or your rod, the metal, what it's melting, and then you got the flux. And let me just talk a minute about the flux on it. Weld has to be a pure process. If oxygen gets into the arc down here, then it contaminates it, pinholes your weld, which makes your weld no good. So the flux is on there to burn. Now, you know, by talking about it a little bit earlier in earlier lessons, you're about 10 to 11,000 degrees off of this arc right here. It burns this flux. And by the way, a 70-18 has powdered iron in the flux. That's the reason it has kind of a grayish tint, which hardens and anneals that weld and makes it very strong. And what happens is it puts off a layer of carbon dioxide around that arc, and it actually has its own atmosphere. That's how the weld works. Without that, it will not work, it will not weld, it will not hold. Now let me say this, how do you weld underwater? Fire and water don't mix, right? Well, in their gun, it's designed for that. When they put it on there, it strikes an arc, and an inert gas comes in around that arc, and right where that weld is, there is no water. It pushes that water back. That's how it works. So, right now we're in an ocean of air. We're in an ocean of air. Breathe. You know. Well, when I start welding, that air, just like that water can't be in that arc, that air can't be in that arc. So this carbon dioxide right here, burning off this flux, puts me a layer around this weld where there is no air. And thus it welds, and we get a quality job out of it. Now, after it's welded, and I went ahead and done a quick bead right here, I want to show you something that has cooled off. This is my chipping hammer. Now, the flux, after burn, turns into slag. The slag just coats, it stays on there. You have to remove it after we weld, and I'm going to do that right here. Let's see if I can get it in one piece. There it is. See, there it is. That is this burned up. It stays on the weld. There it is, that's slag. And underneath it now is your weld. And there it is. There's a weld. So that's how that works. It burns the slag to create a pure atmosphere with no oxygen in it and gives you the weld. Now, in order to weld, if you're flowing electricity through this system in which you are, if you close the gap, if you leave no gap right there, then you've made a solid connection and your arc is going to stop. So you have to learn. One of the hardest things to learning to weld is to learn to get the gap. And I get students sometimes that are way up here. They think that's a gap. That's not a gap, that's a canyon in welding, for welding. A gap is just thousands. And anytime electricity, let's say this is a plate and this is our rod, for instance. Well, if there's a gap there and electricity has to go from here to here, it creates an arc. And an arc creates heat. That's how it does it. And we're flowing enough electricity through here where it creates massive amounts of heat, 10 to 11,000 degrees, give or take, depending on where your amps are set on the machine, to create the gap, create the arc, and then you're welding. Now, there's two types of current that we use in welding. Two types of current you use anywhere, but machines work. I'm just going to do a quick run through on it. You've got, on our setup right here, we've got 240 volts AC service going into this rectifier machine. Well, it goes in AC, the rectifier converts that current into DC current that we use to weld with. That's direct current. That means alternating current, or AC, alternates back with 60 cycles per second. But DC current flows. It flows from negative to positive or positive to negative, whichever way you've got it set up. I'm set up in DC EP, which is direct current, electrode is positive. So when I'm welding right here, now, with this positive, the current is coming down this ground lead into my workpiece, back up, and back to the machine. That's the circuit. It's direct current. It's running directly from here to there. Now, if I went over there and switched these cables and say this made, that is my ground now. This is my stinger. Now the current would be coming down the rod, through my workpiece, and then back. Now, you might ask, well, why? Why would you want to do that? Well, I'm going to tell you. When I'm running with my electrode in positive setting, I get less heat onto my arc and more heat into my workpiece. That helps it to, like if you're doing out of position welding, or whatever, like vertical or overhead or whatever. Now let's say I want to do build-up weld, say lap beads or surfacing. Say this is wore out and I have to build it up with a lap bead. Well, I'm wanting those welds to stack up as high and get as much height out of each bead as I can get. So I switch the polarity in order to do that. In the straight polarity, in other words, your beads flatten out more. In reverse polarity, your beads will stack up more and give you a higher bead. All right, now that is the basic run-through of stick welding. Just remember, two polarities. DC EP, it means important. Direct current electrode, positive, or DC EN, direct current, the electrode is negative. And I'll explain why that is. So, at this point, we're going to set up here in a few minutes, and I'm going to run you a bead and show you what this looks like as you actually do it. All right, guys, now we're getting ready to actually run a bead here. with a 7018. Now let's just take a second about our safety. We've got our welding helmet or hood. Talked about those. At least the number 10 shade. We've got good gloves on our hands. Our piece is grounded. So we are basically ready to run the. And I just want to show you what it looks like underneath these hoods. And you'll see. And welding takes a lot of practice because you're always working in the dark. You have to strike an arc to give yourself a light to even see where you're going, because these hoods are very dark. That's how they protect your eyes. Here we talk about the filter lenses in your hoods. Filters out the ultraviolet rays and causes no problems to you. So let's fire a machine up and run us a bead right here. That's what welding looks like. It's dark and sparks are flying out, but you're actually putting this weld down. And here's what I did. You see my bead right here. I put it right down on the edge, and I have some slag on there, remember? And it's there's what? Very little effort. Now, I want to say this. If it takes much more effort than that to get your slag to come off your weld, then you need a little more practice. That's just all I'll say about it. And the thing about welding, folks, is the first bead you run, the fifth bead you run is probably not going to look very good. It takes practice. It's a skill that you've got a term in welding. It's called L.A.S.H. L.A.S.H. L-A-S-H. And what that is, the length of your arc, the angle, the speed you're traveling, and the heat that your machine is set on dictates what kind of bead you're going to get from this welder. If any one of those things are off, and I'll take just a quick second and tell you, the length of the arc. Well, I done talk about that a little bit, but I didn't talk about the angle. The angle of your rod depends on which way your weld is going to go. Now, if I wanted to put another bead on it, if I was surfacing this, would I want to angle this rod this way? I don't think so, do you? Because then I'd be throwing the weld this way. I want to angle that rod right in here, in that gap, and it will put that bead right over on this bead, and you'd get a good tight bead. And the speed of travel is very important. It was very, very important. It will only put weld down at a certain speed. So the speed you're running, it just packs them beads right up. It's inches per minute is how a weld is measured. So it's slow. And of course the heat. There's that perfect place. Where that perfect place is at depends on which machine you're running. If you've got 4 machines, they're exactly the same, but they all will set a little bit different. And there's many reasons for that, but we'll not get into that right now. That is in our electrical part of this arc welding. But remember that term, lash. The length of your arc, the angle of your rod, the speed you're traveling with the rod, and the heat that your machine is set on. Well, I hope this helps you in your endeavors to weld and learn about it. And there's more to come, we hope. And till the next time, I will see you. And I need a grinder to show you this.
You know what?